This is the activity which relates to 3D models, that is three-dimensional models. So the objective of the activity is to make some 3D models and then verify the Euler's formula for the polyhedrons. Let's study the concept in hand first. Whenever you have a polyhedron like a triangular pyramid maybe, or a triangular prism, so these are all polyhedrons, a triangular pyramid or a triangular prism or a pentagonal pyramid, or it can be a square prism. There are so many polyhedrons. They have three different things in them. One is the faces, that means the plane surfaces, the vertices, that means the corners, and the edges, that means the sides. So these three dimensions, that is faces, vertices and edges, the number differs in different type of polyhedrons. So you have a value of F, you have a value of V, and you have a value of E for each type of 3D solid. There is a formula which relates the values of F, V and E for every polyhedron for that matter. V plus F minus E will always be a constant. Whichever solid you take, you find V, find F and find E, add V and F and subtract E from that, the answer will always be 2. This is a property of polyhedrons which is known as Euler's formula. And that's what we are going to verify for 3D solids in this activity. The material required for this activity is white paper, isometric dot paper, pencil, geometry box. We can take blocks of unit cubes also to make some polyhedrons. Let's see how this activity can be performed.
So in this activity, you will take some of the pyramids and prisms which are readily available to you. Like I have taken, this is a prism, this is a pyramid, this is also a pyramid, another pyramid here and a prism here. So what you have to do is, like if I pick up the triangular prism here, this triangular prism has how many vertices? So we will find out the number of vertices first. V stands for vertices. So 1, 2, 3. 3 corners here and 1 corner here. So there are 4 vertices. So V is 4 for this solid. And then F. F stands for faces. How many faces? Like flat surfaces? 1, 2, 3 and 4. We have 4 flat surfaces. And how about the edges? Edges means E. Edges are the sides. So 1, 2, 3 and at the base 4, 5, 6. So you have to draw 6 lines to draw this figure. So those are the edges. Now if you substitute these values of V, F and E in the formula V plus F minus E, you will get 4 plus 4 minus 6 and that is 2. Euler's formula states that the sum of V plus F minus E should always be 2. So this is verification of Euler's formula for this triangular prism. Let's take another example where we have a prism. So you can write the name of the solid on the left and then start verifying the formula. Vertices, the corners. So 1, 2, 2 on the top and 4 at the base. So overall there are 6 vertices. How many faces? 1, 2, 3, 4 and the base 5. So there are 5 faces. So how many edges? 3 here, 6, then 7, 8 and 9. So there are 9 edges. So 6 plus 5 minus 9 and that gives you 11 minus 9 which is again 2. So you can see we have verified Euler's formula for this prism also. Likewise, you can take other solids, write the value of V, F and E and put it in this formula V plus F minus E. You will always get 2 and that verifies Euler's formula for various solids.